Okay, so here it is, the course web page, and as I just said that I try to record all of my lectures. And the reason for this is that if someone is sick, if they can't attend lecture, then they can always watch the lecture online. Or if you don't want to come to lecture and you're at home and coming to this lecture doesn't fit your schedule very well, once again you can review the lecture at a time that's convenient for you. That's the reason I've been developing this technique of recording my lectures and putting them on YouTube. So I'll make those available this quarter. In fact, you can see my my older lectures, and I'm basically going to follow the same format that I followed in the last two versions of this course that I taught, with some small changes. For instance, I removed an assignment and so on. But everything that you need to do this class is actually on the web, and you can read through the materials that I've posted on the web and do the assignments. You can do everything outside of lab and outside of lecture except taking the 3 quizzes and the final. So there's 4 things that you have to come to, for which you have to come to campus. 3 quizzes and a lecture, and a final exam rather. But even though you can minimize your travel to campus that amount, that I'm not recommending it. I'm just saying that if that suits you, then that's what you can do, but I'm not advocating it. Especially the labs, that it's very useful to come to the labs and work together as a group, because in the lab environment, we all get to help each other learn what we need to learn in that environment. All right, so I guess what we can do is maybe just glance at the syllabus and talk about that for a moment. And that's the first link on the course web page. My office hours on Tuesday afternoons. And these are the meeting times for the lecture and the labs. The prerequisite for the class is stated here. It should have some background writing computer programs, some kind of experience doing that. If you haven't had that, then the class is going to be more difficult. But so you can use your judgment whether you think this course is the appropriate level for you. If you feel that you're a little weak in that area, that we recommend this other class in which the students are learning a language called Visual Basic. And that's a good warm-up class to take this class, Computer Science 201, Introduction to Computer Science 1. All right, so basically, let's see, the course format. We've got a book. This is what the book looks like. And I think it's expensive, but it's a good book, and I've searched for a free alternative to this, and I haven't found anything. But you're welcome to try to do some kind of alternative to the book. Actually, the book is very standard, and there's many books that cover essentially the same material. So if you've taken this class or a class similar to this, and you have a textbook from that class, it's likely to be good enough for this class. So if you've taken a version of this class at another university and you still have your textbook, then what you can do is show me the book, and I'll tell you whether it's equivalent to the one that we're using here. And these books, there's many of these books available, and they all roughly cover the same stuff. So that's another way to save cost there, by not buying a new book if you don't need to. All right, so the class, I would say that this class is challenging. I would say it's challenging like a math class would be challenging, or a physics class. So I would put it in that category of level of challenge. It's a problem-solving class. You have to be a creative problem solver. So you're going to be learning a language called C++, and then I'm going to give you a sequence of challenges or problems. They're not big computer programming problems, they're small, compact problems, easy to solve, well, not easy to solve, but solvable in a short period of time. And so you'll get a sequence of these throughout this class, and that's essentially the format of the class. I'll be solving a lot of the problems that you'll be doing in lab. And so then when you go into the lab, you will have seen me do most of those problems in advance during the lecture, and we talk about it and talk about the concepts and the principles and the techniques behind the solution to those problems. But then there's going to be some problems that I won't cover in lecture that you'll need to solve on your own. And then there are quizzes, 3 quizzes and a final exam. And that's essentially the format of the course. Now the final exam will look like a big quiz. So the questions that are on the final are very similar to the questions that are on the quiz. It can actually be copies of the exact questions I gave on some of the quizzes. I do that all the time. So just the point I'm trying to make is that you'll see there will be no surprise when you get to the final. You will have been trained to ace the final. Well, that's my goal. I want everyone to ace the final. Of course, that's not going to happen, but that's what I work for. So I don't surprise you when you get to the final. And that's because the quizzes give you a warm-up for that final exam. And now the quizzes, in the same way, I don't want you to be surprised in the quiz. So I give assignments, and the assignments warm you up for the quizzes. So they all sort of tie in together. And you get points for the assignments, you get points for the quizzes and labs. Here's the table. That's how the different graded things are, or activities in the class. These are all graded. So there's reading. That counts as 10% of your grade. Labs, assignments, quizzes, and final exam, and so on. How do you get graded on reading? You just say, I did it. Then you get the points. But for labs and assignments, what you're going to do is you're going to solve the problem. That means you're going to write a computer program. And then you're going to copy that program into what's called a source code repository. Now, each of you will have your own source code repository, which is something that professional software developers use on a daily basis. And you're going to write your solutions into this repository. And then the course grader, his name is Jaron Willis. He's not here right now, but he's been my grader for a couple of quarters now. That he will retrieve the programs that you wrote in lab and in the assignments, and then he'll test them. He'll make sure, yeah, they run. He can run them. He'll look at them and make sure that they pass the criteria that I set for well-written programs. So the program needs to run correctly, and then it should follow some kind of a quality check in terms of readability. So your program needs to be readable by the computer. That means you can run it and it does the right thing, but it also needs to be readable by humans. So it has to have some quality in that area, and I'll talk about that as we go through the class. So, and let me tie this in a little bit with what some of you will probably be doing in your careers in the future, and that is writing computer programs. I'm sure that many of you will actually need to write code to solve problems in your career after you graduate. And some of you probably are doing that now, may even be doing that right now. So more and more, obviously, there's been a lot of automation of information, and automation in manufacturing, and like, you know, robotics and assembly lines and so on. Did you need a place to sit? Is there a chair? There's one here and there's one here, and just come right on. The lecture will thin out, by the way, you know, because I make the lectures online and all that. So this does thin out. This is the most people will have all at one time, except during that quizzes in the final. Then we see everybody again. Yeah, I don't know how much of a case I need to make about that, but there's a lot of business activity involving computer programming, coding, and it appears to be growing. And I know that right now, you know, I'm a professor in the School of Computer Science and Engineering, and the students that are graduating with our majors are finding it relatively easy to find work right now. It's not always like that, but you know, 5 years ago it was tough. 4 years ago, 3 years ago even, it was tough. It's quite cyclical. But in general, over the last 30 years, that jobs have in general been very good for people with the kind of skills that you will learn in this class. And those skills are problem-solving skills related to the automation of information processing. So information is represented in digital form, you know, when as character data in a file or numerical data in a file, and then processed using software that someone writes. So we're going to learn about not how to use software, we're going to learn how to write software. But actually, there's a fuzzy line between the two, because writing software involves learning how to run a lot of software as well. For instance, there's something called a compiler. It takes source code, which is your computer programs are written in source code. It takes that source code, and the compiler is a program that runs and translates the source code into machine instructions. Those are the sequence of numbers that the computer interprets and carries out what it needs to do. So we're programming the computer. We're telling the computer how to do a task. And we use tools. So we're the ones that building the tool. We're the ones that writing the program that's going to do the information processing. But we're using programs, we're using tools to build our tool. So it's like that. And of course, the most important tool that we're going to learn about is the compiler. It's the program that translates the source code, the human readable source code, into machine readable machine instructions. That's one program. Another program we'll use is, of course, the operating system. I mean, the operating system is a program. Although maybe you could say it's not, I'm not sure that there could be the definition of the word program does not include operating systems. Anyway, it is an operating system is essentially the same as a program, but it's the first program that runs when the computer boots up. So it sort of takes over. And then the programs that we'll be writing in this class, we're not going to write the operating system. We're going to use the operating system. We're going to write programs, and we're going to give the programs to the operating system and say, here, please run this for me. And then the operating system then launches the program. But the code for the operating system looks just like the code for the programs that we're going to write. They all have loops and conditionals and variables and assignments. It's even the same language. I mean, the big operating systems out there are written in C or C++ or something like C or C++. And that is the language that we're learning in this class. It's called C++. That's a computer language. And that's one of many languages. Okay. Let's see, I've got 2 course goals written out here. Learn how to write programs in the C++ language. That's the first goal. The second goal is to improve computational thinking skills that can be used to solve a wide range of problems. So if you learn how to write programs in this class using C++, then you gain a generic skill, a general skill that you can use to write programs in all the other languages. They're all very essentially the same thing. They all have conditionals. They all have something like, if the temperature is bigger than 90 degrees, then wear a t-shirt. Else, wear a jacket or whatever, right? So that's called a conditional. We're looking at some information and we're making a decision and we're taking one action or over another action based on the state of that data, that information. All of the languages have constructs that let you do that. So so whatever language you really, it's kind of arbitrary which language you want to start with. It's not 100% arbitrary. There's other factors involved, but for the most part, you can start to learn about computer programming. You can start in any language. And what you learn in that one language will carry over to all the other languages that you could use. So you're going to be developing very general, useful skills in this class. Well, I remember, I just forgot to mention something about the final exam. The final exam looks like the quizzes look like the assignments look like the labs, and the labs look like what we do in lecture. It all ties together. And then I want to say, for those of you who will seek employment as software developers, your interview may look like the final exam. And that is really true. You'll sit down and they'll give you a problem. They'll say, write a program that it looks at every number in a sequence of numbers and calculates their average. I don't know, something like that. So they give you a problem, and then they'll walk away and you'll sit in a room and you'll come up with a solution. All right. Let's see. I think that's it. Any questions about the course format or the grading or the syllabus or my expectations? Anything about how the course works? Yeah.
In regards to the textbook, this is the second edition. Would you recommend that the first edition?
The first edition is okay. They make some really small changes from one edition to the next, and they charge you $100 to buy the next edition. Is that a secret that you don't know about, or is that something that... Okay. Any other questions? Oh, and Blackboard will be, we use Blackboard for the reporting. Like when you do the reading, you'll log into Blackboard. And it's not set up yet. I think maybe today or tomorrow the Blackboard will be set up for this class. So it's not currently set up. But when you complete the reading, you'll go into Blackboard and check it off. I did the reading. And then when you do the lab, you go into Blackboard and check it off. First of all, in the lab, you have to commit your work to the repository, and then you go into Blackboard and say, I did it. And so on. And then the results of the quizzes are also reported through Blackboard. You don't do anything in Blackboard, but you can look at your grade there. So we look at, we use Blackboard mainly for managing the grade, and so that you can see where you stand in the course and see, well, yeah, hey, I submitted that lab, and why isn't it in the grade book? So you can, we make mistakes here, so you want to keep an eye on, what I have as a record of you doing, right? And just in case we miss something. Let's take a look at maybe this. This is the reading. This is all the readings. Is it 6 readings? 6 chapters, right? So some of these deadlines I didn't set yet. This one is absolute deadline here. So that was the first deadline I set, and then this is is this today? No, that's next week. Is that next week or the week after? January 18. That's 11 days away. It's more than a week away. Or 9 days away. Today's 9, so it's 9 days away. It's a week and 2 days. So reading 1 is due in a week and 2 days, as well as lab 1. That doesn't mean don't do the reading on January 18th. Don't do the lab on January 18th. Do the lab today. Do the reading tonight. Because some of the problems are going to take more than one sitting to solve. So you've got to get an early start. All right, the first chapter is good. It doesn't really have much that's critical. I mean, the underlying concepts are important to understand about what a computer is. So you need to read that for that reason. But what is also very critical is that you start to learn about the Unix operating system or the Linux operating system. And Linux is a variant of Unix, right? Unix is a more type of operating system. And there's this nice tutorial here, and what I want you to do is go through the 6 chapters in this tutorial. You don't need to do 7 and 8. I mean, if you want to, you can, but these we won't need in the class. But the material covered in these 6 chapters on Linux will be useful to you. And so that's part of the reading. In fact, the lab, let's take a look at lab 1. And lab 1 is to do those tutorials, to read through the 6 chapters and perform the sample commands that they show there. And maybe we'll do a little bit of that today, just to show you what I'm expecting from you. Let me go back to the reading. So this is the first chapter of the book. It's the overview. What is a computer? What is a program? And this is an explanation of the command line interface. You know, let me explain that about the operating system. Every computer has a program running in it called the operating system. And it's the program that loads up in the computer when you power on the computer. When you power on the computer, the hardware goes somewhere. It goes to the disk drive and it reads sector 0, byte 11 or whatever it is. There's some convention there. And it starts to load machine instructions from the disk drive. And then it executes those instructions. There's a bootstrapping process there where there's a basic set, there's a bootstrapper that's kind of coded as part of the hardware that reads the operating system, loads it into RAM, and then starts to execute it. And so this underlying code or logic called the operating system has a human interface. And in the old days, there was, it was like a typewriter interface or a card reader. I mean, it's something really primitive. And then at some point, they had monitors. And in the monitors, you could type in commands. And then the computer, you would type in something. You would say, hi. And the computer would type back, hi. Or I don't know, whatever. You'd have it's like a conversation. You tell it to do things. You say stop, and then it stops. Or you tell it to, run program XYZ, and then it will go and run that program. So you tell it to do things. And before graphical user interfaces, that was done at the command line. So you would type in these words, list the contents of this folder, and it will generate a list on the screen. And that's called the command line interface. And then at some point, when computer hardware got more powerful, and the operating systems that ran on on the more powerful hardware, they became more sophisticated as well. Then we started to see the graphical user interface. So now instead of typing, show contents of folder X, then you double click the Windows Explorer icon or go to My Computer, and it pops open this tree with branches, and you start opening the branches and searching for a file that you're looking for. So that's the graphical user interface. So in general, there's two ways to communicate, for the human to communicate with the operating system. One is through the command line interface, the other is through the graphical user interface. And in this class, we're going to learn how to communicate through the command line interface. And the command line interface is, programmers use the command line interface a lot. Not just programmers, system administrators use the command line interface even more than a programmer uses. Now, the command line interface is a very important way of controlling and interacting with the operating system. And that's one thing that you will be learning this quarter. And we're going to be practicing using the Linux operating system. And if you have a Mac, like a MacBook or just a Macintosh computer running OS 10, you'll see all the commands that we're learning here in Linux are identical to the Mac environment. Because the Macintosh, the recent versions of Mac, OS 10 it's called, are built on top of a Unix variant like Linux called, it's either FreeBSD or OpenBSD. I don't remember which one it is. One of those two. So BSD, that's a variant of Unix. So the Macintosh is built on top of a variant of Unix. And the commands, in fact, the source code that is compiled into the executable that runs on the Macintosh is the same source code that's compiled and executed and run on a Linux computer. The Windows is different. Windows is quite a bit different. So they have the command line interface on Windows is similar, but it's not practically identical. The Mac, OS 10, and Linux command line interface are practically identical, but the Windows command line interface is significantly different. But they have the same functionality. Right? So on Linux, you type in ls to get a list of folder contents. The same on Macintosh. But on Windows, you type dir. Oh, right here, look at this. This is the terminal window, the command prompt. dir. dir is the command. So it shows you a listing of folder contents. So the goal of the first lab is to get you going with the command line interface on Linux. And let's go ahead and do that. And let me just jump to the lab here.
Professor,
Yeah.
is there anything that we need to, like, software that we need to get for this class?
Yeah. If you work in the lab, of course, you just work in the lab. But when you work at home, and you should and must work at home, actually, that all you need is called is an SSH client. On I think I talk about it here. Let me see the preparation. Oh, how to work remotely using SSH. Right there. So what you can do in this class is you can log into one of the lab machines from your laptop or from your desktop machine at home. You log into a lab machine and you just work on the lab machine remotely. But you're going to do that using the terminal window. you're not going to use a graphical user interface. So that means you work remotely. You can also work locally if you want to install a compiler on your machine. You know, if you're Windows and you want to install Visual Studio and use that, you can do that. And I tried covering that in previous classes, but it kind of overload everybody. So I'm making it simpler now. But if you want to run your own compiler locally on your machine, I'll support that. I'll help you, you know, get that installed and configured and running correctly. But to work at home here, the minimum is you need this program, an SSH client. On Windows, it's called PuTTY. Let's see if I have it here. Oh, I need to fix that link. This is the link here. By the way, this is my first time using Google Sites. So I'm moving my course web pages to this new format called Google Sites. It's very convenient, and but this is my first time using it, and I've been using a wiki system, you know, like the Wikipedia software. I've been using that to create course content and manage my courses, and this is my first time using Google Sites, so just kind of have to bear with me. This link link I didn't fix coming over here, so I'll fix that later. Well, this is the format. See that little brace there? Yeah. This is the format that you use to create an external link on Wikipedia. Oh, okay. So it's not displayed as a link. Right. And so when you see that, you'll know what's going on. I think, you know, if you sign in here, you might be able to post comments on my web pages. I'm not sure. I'm trying to figure out how to get this thing to work. So if you have some ideas on how I can better make use of this Google Sites, let me know. I would like to have like a comment section, you know, where people can post questions and comments on the bottom of my page. So I'm just getting used to this. So if you can help me do that, that would be great. So that link goes here. This is it. This is the page you want, the PuTTY. Now, if you do a search on PuTTY, you might get to some other site. You know, this is free software. Okay, this is free software, and this has been around a long time. This is heavily used. This is a very a significant piece of software. Let's see what we get when we go to Google. Look at the first link is that one. It doesn't look like a professional site though, right? I'm not sure about this one. Oh no, that's good. That's a good one too, actually. Here's another way to get it. Well, maybe you would trust this site more because it looks prettier, right? But I wouldn't trust this site. You're going to get, you know, spyware, or you're going to get a tool installed in your browser to help you do your work better. So I wouldn't go here. So I'm giving you the link to the authoritative website there. This is where you can get it. And by the way, this is just for Windows. Question?
I was going to ask, which operating system would be best for this class?
I think a Macintosh or Linux is the best. And Windows is okay too. I mean, I do most of my work on Windows, to tell you the truth. I mean, I work a lot on Windows. So, but this class is looks more like Macintosh and Linux. And in lecture, I'll be working on Windows. So I'll show you how to do all the problems using Windows, which just means I'm going to run SSH, and we're going to connect to the lab machine remotely and do our work on the lab. So we're going to be working on Linux anyway. So this one here, you know, download this and install it, and then that, you know, basically it gets installed, and there it is. And you'll connect like this. JBH 3-1. You need this URL. .csc.csusb.edu. So that is the host name that you want to connect to.
You said it was
JBH, Jack Brown Hall, 3-1. I think it's on the web page here. Let me just check that. There it is right there. Okay, it's all the instructions. Everything I'm telling you now is right there. It's in the text format on the web page. So you put the host name or the IP address, and but you don't know the IP address, so you're going to need to use the host name, and then connect. Then you open, log in as, and here you need to type in your username, and your username is something like. You have to come to lab to figure this out, by the way. So there's some technicians, our system administrators, that set this up for all of us, and they've created an account for all of you. If you don't have an account yet, if you haven't taken a class in the computer science department yet, then an account will be created for you, and there's some pattern. It's like your name, your last name with the first initial, and followed by something. So there's some pattern there. I don't know what it is exactly. You need to come to lab today and get that information. So I'm Turner on the system. Notice I don't see stars here, right? I was typing in, so you're not going to see stars. You won't see anything when you type in your password. Now, look here. See, this is the command line interface. I'm logged into a computer that I can reach through the internet using the host name jbh3-1.csc.csusb.edu. Okay, that's the host name. The DNS system, the domain name system, takes that host name, translates it to an IP address. It's a number, 4-byte number. And now my local computer here has made, an agreement with JBH3-1 to exchange information over the internet using some conventions called TCP, and they agreed. The two computers agreed on a port on port numbers that they would use, and so on. So now we're talking to each other, and this is the terminal window that's running on JBH3-1. That's different than this. This is the terminal window that's running on my local machine. So, see, ls doesn't work here. ls is not recognized as an internal-external command. ls is a Unix command. ls will work on JBH3-1 because it's a Unix system. Now, we don't want to work on, now here's the thing. The university has a lot of computers and there's a lot of labs, and those labs are always being hit by hackers all the time, and so we've got to put up firewalls and control things. So you can't log directly into one of the lab machines. You have to go through this gateway, JBH3-1. That's the gate into the computer science network here at Cal State San Bernardino. So once you log into JBH3-1, you're now in the campus network. Now you can log into you're in the computer science network. And then from there, you have access to the lab machines. So I'm going to log into JB359, that's the room where we meet for lab. Jack Brown, not a hall anymore, 359 say 4. There's about 30 computers in there, and they're numbered 1 through 30. Now you can see the prompt has changed. Turner at JB359-4. It's just a reminder. It's showing, that's called a prompt. The prompt is the place where you type in the command that you're going to give to the operating system. The prompt has got is displaying some information to us. It's showing us the host name. Host name. When you hear the word host, what's that mean? It means computer. That's all it means. Actually, it means computer connected to a network. Nothing more than that. So it's called a host name, and that's it. Now I can see this is a command users. I'm the only user logged into the machine. If there was someone upstairs in that lab logged into that computer, I would see their username. And I could send them a message as well, right? It would show up in their terminal window. So it's here where we can do our work. I'm going to log out of here. So this window here, you know what? It's too small, right? I remember that's a problem. Let me increase the font. I think that one's good enough. Is that better? Yeah, I think so. This is what's called my home folder. PWD, print working directory. You know, these command names, by the way, these are ancient, and they don't always make sense today, right? And but they're from the past. So PWD, print working directory, but that's not too bad of a name. So this is the path through the file system. U/faculty/Turner. Clear, that means just to clear my screen. Print working directory. That's an example of a command. Now this is the same on Macintosh. You know, you've got the same commands. But now don't forget, I'm running on Windows here. But I'm working. I'm logged in remotely on a machine in the lab, and now my commands are being executed on the machine that's in the lab, not my machine here. This machine here is just sending data to that machine over there. So when I go print working directory, what we have here is what's called a file system. So the information that's stored on the hard drive of a computer, or in a flash drive, or in a CD-ROM, or they call it persistent storage. You turn the computer off, the data's still there. Turn the computer on, the data's still there. That's called persistent storage. So what the file system normally is your disk drive. And you know, the data is stored in your disk drive, but it has to be stored in some kind of a manner, right? It has to be organized. So you don't put all your data in one file. You don't put it all in one place. You break it into files. You say, well, this is my Excel spreadsheet, and this is my Microsoft Word document here, and so on. So you break your data into files, and of course, you know, there's too many files just to dump in one place. So you need to have folders. So you have a hierarchy of folders. You have folders within folders. And it forms a tree. You've got a root folder. And the root folder is usually designated with a slash. So I want to look at the root folder. I go ls, and then that's list. List contents of the following directory or folder. The word folder and the word directory mean exactly the same thing. The word host, the word computer mean exactly the same thing. Well, I think host implies the computer is connected to a network. So list / that's the root folder. those are the folders. That's the contents of the root folder. The color is not good. I gotta turn the color off. Colors. There we go. That's the contents of the root folder. And you know, it's the same on Windows too, right? So I can go, I don't use ls, I use dir, so I can use slash. Whoops, you know what? They do everything the other way. So they use slash in the other direction. That was a dumb decision that Microsoft made a long time ago. But actually in programs, if you use a forward slash to use a slash to separate folder names, and at the end of the string, you're separating the folder name from the file that's in that folder. But in Windows, sometimes the forward slash works, but in the dir command, it doesn't work. So we can look at, for instance, what's in this bin folder. So slash bin, ls/bin. These are the contents. There's a lot in there, right? Too much to look at. So I'm going to use an up arrow. I use up arrow. It's called command history. So I get my last command that way. Or I can go back several commands. I use the up arrow, go back through commands that I've entered in. It's called the command history. Up arrow, down arrow. It's very useful. And I'm going to pipe that through another command called less. And then I can see the files like this. I use the left up and down arrows to see the contents of that folder, because it won't fit all on one screen. So these are examples of commands that you need to learn. ls, you need to learn ls. This piping command, you know, less, you know, that's kind of optional. You don't really need to learn that. But ls you need to learn. Another command that you need is cd. cd, change directory or current directory. So in your file system, you've got this hierarchy of files. You've got a root folder and all the subfolders under it. And when you have this concept of a current working directory or a current directory. When you run a program, there's this assumed location in the file system that operations are relative to. So if I do ls like this, it means show me the contents of my current working directory. If I go pwd, it's print working directory. That's where I'm located in the file system. If I cd 201 like this, I'm going to change my directory to the subfolder called 201. Now you'll see I've gone down a level in the folder hierarchy. Now I'm inside 201. 201's inside Turner. Turner's inside faculty. Faculty's inside U. And U is inside the root folder. And I do ls, and I can see, oh, these are from last quarter, right? I've got some things left over from last quarter. But I don't need these. This is a dangerous command right here. This is recursive force. You know, when you're at the command line, there's no trash can. When you delete something, there's permanent deletion. You can't undo. So this is a little dangerous. Would never do this in your root folder. You're going to wipe out your account. So when I do this, you know, I'm really careful here. Because if I was not in 201 and I was in my root folder, I would just crash. I mean, I wouldn't be able to log in again. So it's a little dangerous. Everything still work? Yeah. Okay, good. But I cleaned it out. I just deleted everything. Once again, there's no undo here. It's gone.
Is the star part of the command?
Yeah, star is wildcard. It matches against everything. Now the command, RM is removed. Yeah?
If you hit rm space dash rf, and then you can type in a file to delete.
Yeah, let's do that. Let's, I'm going to use, let's see, what's a good editor to use is, you know, I use this editor called VI. And I create a little file here. I just created a file called main.cpp. If I use the cat command, I can dump the contents of that file. It just says hi inside of it. And we can delete that. I go RM, that's remove. I'm going to remove main.cpp. Well, that's it. So you have a command, RM, space, and then it has the arguments. In this case, we are using a single argument, the name of the file to be removed. Well, how do we know that it was removed? Well, we got to check. I'm going to use ls and see that, oh, nothing. It's gone. I think you can use this touch command too. Let me try that. That creates an empty file, by the way. When you touch a file, you set its last change date to the current moment. But if you touch something that doesn't exist, you actually create an empty file by that name. Now, VI is a very old text editor. You know, text editor means, let me explain what text editor is. Wait, we go to 115, right? A text editor is a program that you use to edit text files. And a text file is a file that contains simple character data. Microsoft Word documents are not text files. They do not contain simple character data. They contain binary data. And so, but files that are used to configure the operating system are almost always simple text files. And VI is used to, and also source code. Files that contain source code in C++ or JavaScript or HTML, you know, that all the different languages. Those files are simple, are text files. They contain simple character data. So a text editor is used to edit simple character data. VI is a very old program, but it's difficult to learn. But the benefit of VI is that it's everywhere. It's in every Unix system. So, you know, on your Macintosh computer, VI is there. You don't have to install it. It's just there. And when you're a system administrator and you're like, system administrators doing what we're doing today, we're using this SSH, this PuTTY program, logging into the remote machine and doing operations. A system administrator does that constantly. They're always logging into different systems located around the world or around the building or whatever, and they're modifying configuration files. So they're using text editors. VI is everywhere. So you know you can, if you're going to be a system administrator, I think it's great to learn. But it's very old, and it's got kind of like this archaic command set and interface that's difficult to learn. So I'm not sure I recommend it. Let's see, what would be an alternative? There's something, I think Nano. I'm not sure if I can't remember what people are using. Oh, Nano works, and there's some other programs in there.
Are these all
These are Linux commands, but they also work on Macintosh. But this nano, that's not going to work on Macintosh, but VI will. LS will. You know, CD, that command works on Windows. Some of the commands that work on all 3 operating systems, like CD. But some of the commands don't, like LS. LS works on Mac and Linux, but on Windows it's DIR. So this is Nano, and there's some other editors in there. I don't remember what they are. And I'm going to do, and it shows it down here. See this caret symbol, O, so that's, or control symbol. So control O is to write out. So I'm going to do control O. We didn't give a file name, so I'm going to say main2.cpp, like that. And then control X to exit. Then LS, there it is, the main2.cpp. So I recommend Nano.
What is CPP extension?
The CPP extension means a C++. So that's the standard extension for C++ source code file. I didn't have to do that, right? I could do message.txt would be a common extension, right? Whatever. So if I try to exit now, say I don't use this, but save modified buffer, and I'm going to say yes. So you know, the files that we're creating now, I would normally give them .txt extension, but in the course we'll be creating files with a .cpp extension. And some tools will look at that extension and assume that it's a C++ source code file. So it's a good extension to use. Now, in the first lab is to basically get comfortable using this command line interface. Whoops. And so I want you to go through this. And once you've gone through this, you're going to learn ls, pwd, cd. You'll go through all those basic commands. It's not that bad. It's not too big. This is not that hard. This is not the hard part of the class. And then when you're done that, write a hello program. Let's do that right now. And then that's it for today. Okay. So this is the hello program. This is a program that prints hello in the terminal window. And this is how I would like you to do it. Remove start means remove all files in the current folder. Once again, this is dangerous. Don't do that in your home folder. So if you want to avoid that danger, never use star with remove. So I would like you to make a directory called lab, although it's not important for lab 01, but for the other problems, this is how I would like you to do it. So now we have a folder, and then we go into the subfolder, and let's create main.cpp. And I like you can use a different name, but I like to use the file name main.cpp because it has a function in there called main. And I just pasted that from the web. And these are commands that we're going to talk about. And this is where the cout, this is called the standard output stream. This is an output operator, and this is the string hello dot. And see this \n? That's a special character sequence. That means new line. So I want to print an H, print an E, print an L, an O, a period, and then print a new line character. do line character, something called a white space. You don't see it, but you see the results of it. So you'll see the, you know, in the console window, after you says hello, things will move up and, you know, it will go down to the next line. And I'll do Control O to write out, Control X to exit, clear the screen. I've got a main.cpp there. We go C++, that's the command to run the compiler. Get the name of the source code. Hit enter. That's good. When it says nothing, it means there were no mistakes. I'll do ls. Look at that, a.out. The compiler generated a file called a.out. A.out has the machine instructions. And we can tell the operating system to run a.out. That means load the machine instructions in that file into RAM, into main memory. And then start loading machine instructions from that main memory and execute the commands there. Huh?
I was saying do it, I want to see it.
Oh, here we go. And everyone's waiting for it. This is the climax of the first lecture. There it is. Notice there's a lot of fancy stuff here. You know, if you don't like a.out, by the way, you can change the name by using this switch called -O and say I want to call it main. That means don't create an a.out. Create a main. Let me see. I'll show that to you again. It's a main.cpp. If I just do this, -O says don't call it a.out, call it main. Now I just have an executable called main. I can run it like that. But I don't like to type in the extra -O, so I just use a.out. Why the /? I don't think this is going to work. Oh, see, command not found. Now we're in the file system. We have a current working directory. And when I type this in there, I'm telling the operating system, hey, operating system, this is an executable program. Main is an executable program. Please execute it. And the operating system says, okay, I will find a command called main and run it for you. But it's not going to look everywhere. It's just going to look, I'll show you where it's going to look. It's going to look there. And this is a sequence of folder path names. It's going to look there. It's going to look for main in that folder. It's going to look in the bin folder under R2-011B under so-and-so. It's going to look there. If it doesn't find a file called main, then it's going to look there. If it doesn't find main there, then it's going to, and so on. And it's never going to look in our current working folder. It's not going to look in our current working directory. So it never finds it. So we have to tell it, we have to give it the path. So we could do this. Watch this. This is our current working directory. So we could do it like this. Whoops, that was a mistake. We could say, there's the fully qualified path name to the main that we just created. Now it runs. But instead of typing that whole thing out, we could say, hey, wait a minute, I want to use this special character dot. Dot means the current folder. Slash, I need to separate the folder name from the file name. I got to use a slash. So // and then main. That's what the // is. And that's it. Any questions? Okay. I'll see those in lab who are coming to lab today. And the main purpose today is to get your login, to log in and start practicing these Linux commands.
So it's in 359, right?
JB 359.